from set A to set B a relation F from set A to set B is said to be a function if the following conditions are satisfied. A relation F from set A to set B is said to be a function if the following conditions are satisfied. The first condition is domain of R or domain F is equal to A, that is no element in set A remains unlimited. Hello, on the region? How come that? That is no element in set A remains unrelated. No element in set A remains unrelated. This is the first criteria or first condition that a relation should be considered as function. The second condition is unique preimage should have unique pre-image, should have unique image. Unique pre-image should have unique image. These are two conditions. If a relation satisfies these two conditions, then you can say that the relation is a function. So every relation is a not function. Every function is a relation. Some special type relations are functions. The relation those who satisfy these two conditions is called a function. मैं दीटा condition तुमको भलो की बुझाई दे आगे. I'm going to relation, suppose this is set A and this is set B. Okay. Let R be a relation from set A to set B. Suppose set A contains the elements A, B, C, D, and set B contains alpha, beta, gamma, delta, theta. Okay. Suppose A is related to alpha, B is related to beta, and C is related to theta. D remains unrelated. So if you want to write the relation R in tabular form, it will be A alpha, B beta, C theta. Right? So what is the domain of this relation R? Domain R is equal to A, B, C. Here domain R is not equal to set A because D is not related. If at least one element in a relation set in the domain of the relation remains unrelated, then we can say that it is not a function. A relation will be a function if that relation is capable of relating each and every element of a set A to a unique element in set B. एक केस देख पे तीनटा एलिमेंट रिलेटेड है गोटे अनरिलेटेड रही गला जदि लेफ्ट हैंड साइड सेट माने ए सेट रु बी सेट को रिलेशन होची ए सेट रो यदि सब एलिमेंट रिलेटेड न होई पारछंती it will not be a function. सब एलिमेंट रिलेटेड हेले सेटा को हम फंक्शन कहबा जदि सपोज डी टा डेल्टा सहित रिलेटेड हेतांता एठी ऑर्डर पेयर हम नै थांते डी डेल्टा तले एठी डी भी इंक्लूड हेतांता डी जदि इंक्लूड हबो जदि ए सेट रो सब एलिमेंट रिलेटेड हेजबे automatically the domain of the relation set will be A. This is the first condition. Pratisha, is it clear? Pratisha, बुझिपाल कि बेटा? Write in the chat box. Pratisha, can you hear me? Soumya Ranjan Sahu, yes. Okay. पहले वर्तमान फास्ट एटाला फास्ट क्राइटेरिया हमको रिलेशन फंक्शन हबो कि नाही टेस्ट करिया पई देखिबा जे यदि ए सेट रो बी सेट को रिलेशन होची ताले ए सेट रो प्रत्येक एलिमेंट रिलेटेड हबा दरकार ए सेट रो प्रत्येक एलिमेंट यदि रिलेटेड हेबे ताले ए सेट रो एलिमेंट गुडी को लेफ्ट कॉन्स्टिट्यूएंट हेबे जेतला हम डोमेन लिखिबा डोमेन ऑफ द रिलेशन विल बी ए राइट दिस द फर्स्ट क्राइटेरिया सेकंड कंडीशन unique pre-image should have unique image what does it mean okay let me explain it through an example. This is suppose set A, this is set B. Let R be relation from set A to set B. This is suppose X, A belongs to set A, so X belongs to set A, Y belongs to set B. Suppose X is related to Y by the relation R. X is related to Y by the relation R. Now you can say that Y is the image. Y is the image. X is the pre-image. Y is the image and X is the pre-image. Unique pre-image should have unique image. What does it mean? Suppose more relationally, this is suppose set A, this is set B. R is a relation from set A to set B. सर प्री इमेज अच्छा ଏଟାକୁ ମ୍ୟାଥମେଟିକାଲ ଲାଙ୍ଗୁଏଜ ଏମିତି ତାର ଗୋଟେ କିଛି କି ନାହିଁ ଏକ୍ସ ଯଦି ୱାଇ ସହିତ ରିଲେଟେଡ ହେଉଛି ୱାଇ ଟାକୁ ତାର ଇମେଜ କହନ୍ତି ଏକ୍ସ ଟାକୁ ପ୍ରି ଇମେଜ କହନ୍ତି ଇମେଜ ସହିତ ଯିଏ ଆସୋସିଏଟ ହୁଏ ଦ୍ୟାଟ ଇଜ କଲ୍ଡ ପ୍ରି ଇମେଜ ହେଲା କି ଏଟା ଫଙ୍କସନ ଟା ହଉଛି କଣ ଫଙ୍କସନ ହଉଛି ଗୋଟେ ପ୍ଲେ ଯାହା କୁହନ୍ତି ଲ ଅଫ ଆସୋସିଏସନ ଅର ରୁଲ ଅଫ ଆସୋସିଏସନ ବୁଝିପାରୁଛି ଫଙ୍କସନ ଇଜ ଏ ମେସିନ ଯୋଉଟାକୁ ଆମେ ଇନପୁଟ ଏକ୍ସ ଦେଲେ ସେ ଆମକୁ ଆଉଟପୁଟ ୱାଇ ଦଉଛି ତାହେଲେ ଇନପୁଟ ଇଜ ନୋନ୍ ଆଜ ପ୍ରି ଇମେଜ ଆଉଟପୁଟ ଇଜ ନୋନ୍ ଆଜ ଇମେଜ सपोज ମୁଁ ଲେଖିଲି f of x is equal to x square plus 1 ପ୍ରତିଷ୍ଠା try to understand f of x is equal to x square plus 1 so if the input element x is equal to 0 f of 0 will be 0 square plus 1 0 square plus 1 is 1 so 0 is related with 1 by the relation x square plus 1 here we can say that 1 is the image of 0 under the function x square plus 1 and 0 is the pre-image of 1 under the function x square plus 1. I hope it is clear to you. Pratisha, is it clear? Write in the chat box, yes. Okay. अच्छा से कौन कोची गोटे प्री इमेज रो यदि मोर देन वन इमेज हेइजबो देन इट इज नॉट ए फंक्शन गोटे प्री इमेज रो गोटे इमेज रो अच्छा रिलेशन हम कोन जितने नउची रिलेशन पई तो किसी कंडीशन नाही एपर सपोज नेले एबीसी इट नेले अल्फा बीटा गामा डेल्टा सपोज ए रिलेटेड टू अल्फा ए रिलेटेड टू बीटा बी रिलेटेड टू गामा सी रिलेटेड टू डेल्टा ओके ताले इठी ए वाला गोटे प्री इमेज ए प्री इमेज रो दीटा इमेज रहउची एमटी टाइप जदि रिलेशन थाए ता माने वन एलिमेंट ऑफ द लेफ्ट हैंड साइड इज एसोसिएटेड विथ मोर देन वन एलिमेंट ऑफ द राइट हैंड साइड देन दैट दोज रिलेशंस आर नॉट फंक्शंस ओके एई टाइप जदि रिलेशन ना से फंक्शन हबनी सपोज मैं एमती नेली एबीसी अल्फा बीटा गामा डेल्टा A related to alpha, B related to beta, C related to gamma. One element of left hand side is associated with one element of the right hand side, then it will be a function. Right? What are the two conditions must be satisfied by a relation to be a function? The first condition is if the relation is from set A to set B, every element of set A should be associated with an element of set B. If at least one element in set A remains unrelated, then it is not a function. Okay. The second condition is in the relation, unique pre-image should have unique image. That means one element of the left-hand side should not be associated with more than one element of the right-hand side. That means the relation should be either one type or many-one type. Relation is either one type or many-one type. One-many and many-many type relations are not functions. If two elements of suppose A related to alpha, B related to alpha, C related to gamma, it is a function. Many elements of left hand side can be associated with one element of the right hand side, but one element of left hand side should not be associated with many elements of the right hand side. So note it down. A very, very important note point. One and many one relations are functions. And many one relations are functions. But one many and many relations are not functions. So a function is, to write down definition of function, a function from set A to set B, a function from set A to set B is a law or the correspondence or the rule. Yes. A function from set A to set B is a law or the correspondence or the rule by which each and every element of set A is associated with an unique element in set B. With an unique element in set B. Okay, a function from set A to set B is a law or the correspondence or the rule by which each and every element of set A is associated with an unique element in set B. Okay. For example, this is suppose set A, this is set B, 1, 2, 3. So this set contains 1, 2, 3, 4, 5, 6, 7, 8. So the rule of association is suppose f of x is equal to x plus 1. By this law of association, 1 will be associated with 1 plus 1, that is 2. 2 will be associated with 3. 3 will be associated with 4. Okay, now we can say that this is a function because by this rule of association, every element of set is associated with a unique element in set B. Okay, so this is called a function. If some special type relations are functions, the relation those who satisfy the two conditions. The first condition is if the relation is mapping from set A to set B, each and every element of set A should be associated. If at least one element in set A remains unrelated, then it is not a function. Then the second condition is unique image should have a unique image. That means one element of set A should not be associated with more elements or more than one elements of set B. I hope it is clear to you. Pratisha, beta, is it clear? Pratisha, did you understand what is a function? Then come to representation of a function. Then come to representation of a function. How to write a function or how to express a function. Representation of a function I done. A function can be represented a function can be represented in 4 different ways. A function can be represented in 4 different ways. One is tabular. The second one is set builder. Third one is diagrammatic. The fourth one is graphical. Tabular, set builder, diagrammatic, and graphical. Okay, we'll discuss each by through an example. For example, let A be the set containing the elements 1, 2, 3, 4, and B be the set containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let the rule of association be f of x equals to 2x plus 1. Let the rule of association be f of x is equal to 2x plus 1. So by this rule, 1 will be associated. If you put x is equal to 1, you will get 2 into 1 plus 1, that is 3. 1 will be related to 3. Similarly, 2 will be related with 5. 2 to the 4 plus 1, 5. 2 3 is 6 plus 1, 7. 2 4 is 8 plus 1 is 9. Okay. This method is known as diagrammatic. This is known as diagrammatic. Okay. So same function can be represented in tabular form as f is equal to. So 1 is related with 3. 1 3 order pair will be in function set. 2 is related with 5. So function set contain order pair 1 3, 2 5, then 3 7, then 4 9. Okay. This is called tabular representation of function. This is diagrammatic. This is tabular. Then set builder form. Okay. Then same function in set builder form. How to write? It is written as set builder f map from A to B. It is read as maps from. The synonym of function is mapping. Function is also known as or called as mapping. You can read as f mapping from A to B, or f is a function from A to B. Sorry guys. F is a f map from A to B, or f is a function from A to B. How it is defined? The definition should be written and defined as y is equal to f of x is equal to 2x plus 1. Y is equal to f of x is equal to 2x plus 1. This is called set builder form of representing a function. Then graphical method. I hope it is clear to you. Pratisha, is it clear? Then come to graphical method. You know, class 10 में तुम्हें जानी चाहिए. Each and every ordered pair of real numbers represents a point in the two-dimensional plane. This is called x coordinate of the point and this is called y coordinate of the point. If you want to plot the point 1, 2, you have to move 1 unit along positive direction of x-axis. Then you will have left turn and you will move 2 units. So it will be the point 1, 2. Okay. Here, the function f contains the ordered pair 1, 3, 2, 5, 3, 7, 4, 9. 1, 3, 2, 5, 3, 7, 4, 9. Hello? 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 So the function contains the ordered pairs 1, 3, 2, 5, 3, 7, 4, 9. So we can plot these points. This is 1, 2, 3, 4, 1, 3, 2, 5. This is 2, 5. Then 3, 7. 3, 7. Then 4, 9. Okay. These 4 points are graph of this function. Right? Then come to notation. This is set A. This is set B. F map from A to B is known as F is a function from set A to set B. F is a function from set A to set B. If A belongs to set A, B belongs to set B, we can say A is related to B by the function F. A related to B by function F. Same thing can be written as AB ordered pair belongs to F. AB ordered pair belongs to F means A is related to B by the function F, where B is known as image and A is known as pre-image. B is known as image and A is known as pre-image. Okay. B is known as image and A is known as pre-image. So you can write B is the image of A, B is the image of A, B is the image of A under the function F. B is the image of A under the function F, and A is the pre-image of B under the function F, right? Or A is known as input, A is known as input, B is known as output. If A is related to B by the function F, the same thing we can write B is equal to F of A. B is equal to F of A. So B is the value of the function at x is equal to A. Known as B is the value of the function at x is equal to A. B is the value of the function at x is equal to A. Okay. All these notations you have to remember. These are the elementary concepts of function. Clear? quickly note it down. Pratisha, beta, is it clear? Okay. Then, if it is written that y is a function of x, y is equal to f of x, y is equal to f of x means y is dependent, y is dependent on x. Y is dependent on x. Y is a function of x means y is a dependent on x. The value of y depends upon value of x. And suppose it is written that y is equal to f of x is equal to x square. That means y is dependent on x in the form of x square. That means if you take x is equal to 1, then y will be y is equal to f of 1. F of 1 is equal to 1 square. That is 1. If you take x is equal to 2, then y is equal to f of 2. F of 2 is equal to 2 square. That is equal to 4. Okay. By this functional rule, 1 is associated with 1, 2 is associated with 4, 3 will be associated with 9, 4 will be associated with 16. Okay. So now if you write y is equal to f of x is equal to 2 to the power x. Y is dependent on x in the form of 2 to the power x. If you take x is equal to 0, so f of 0 will be 2 to the power 0 is equal to 1. If you take x is equal to 1, f of 1 will be 2 to the power 1, that is equal to 2. So 0 is associated with 1 is associated with 2, f of 2 will be 2 to the power 2, that is equal to 4, 2 is associated with 4, okay. Y is equal to f of x means y is dependent in x. So what is the dependency form? You can take x square, you can take 2 to the power x, you can take sin x, you can take log x. Okay. Suppose this is set A, this is set B, right? F is a function from set A to set B. Suppose x belongs to set A, y belongs to set B. So x is related with y by the function f. It is written as y is equal to f of x. Y is equal to f of x means y is dependent on x. For different values of x, we will get different values of y or maybe same values of y. So the value of x changes as well as the value of y changes. So x is known as, if y is a function of x is known as independent variable. X is known as independent variable and y is known as dependent variable. Y is known as dependent variable. X is known as independent variable and y is known as dependent variable. So y is a function of x means y is dependent on x. Okay. These are the notations or terminologies in functions. Then come to domain, codomain, range, and natural domain of a function. Domain, codomain, range, and natural domain of a function. Ajay sir, namaskar. Domain, codomain, range and natural domain of a function. First come to domain. Here, domain means domain and natural domain. There is, try to understand what is the difference between domain and natural domain. Domain means restricted domain. So domain is also defined as the set of left elements of the order pairs those belong to the relation set. Sorry, the function set. Okay. For example, you see, suppose this is the set A, this is set B. Suppose the function is f of x is equal to 2x plus 1. Let set A contains 1, 2, 3. And set B contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By this functional rule, 1 is associated with 3, 2 is associated with 5, 3 is associated with 7. Here you can say that domain of the function is 1, 2, 3. Okay. So same function will take another case. This is set A, this is set B. F of x is equal to 2x plus 1. So 1 is 2, 3. 2 is associated with 5, 3 with 7, 4 with 9. Here the domain is 1, 2, 3, 4. In both the cases, you see function remains same, functional 2x plus 1. Here the domain is 1, 2, 3, and here the domain is 1, 2, 3, 4. These domains are called restricted domains. These domains are called restricted domains. But if somebody asks you, what is the domain of the function 2x plus 1? Here domain means natural domain of the function. Natural domain or domain of definition, note it down, it is very, very important. Natural domain or domain of definition. Or domain of definition of a function. The largest set over which a function is defined. The largest set over which a function is defined largest set, that must be the subset of real number, because we are dealing with real valued functions. Both input and output are real numbers. If either the input or the output is an imaginary quantity, then you can say that the function is undefined. So the largest set over which a function is defined is called domain of the function. Domain means natural domain. Domain of the definition of the function. Domain of the function. What do you mean by defined? So guys, note it down. A function is defined at a point means the value of the function exists at that point and the value is a unique value. So note it down. A function is defined at x is equal to a function is defined at x is equal to implies that value of the function exists value of the function exists at x is equal to and it is a unique value and it is a unique value. Okay. If the value of a function exists at a point, then you can say that function is defined at that point. Come to an example. Suppose f of x is equal to 3x plus 1. F of x is equal to 3x plus 1. What is f of 1? F of 1 is equal to 3 into 1 plus of 1, that is equal to 4. Here value of the function exists for x is equal to 1 and that value is 4. Now you can say that function is defined at x is equal to 1. Take another example. Suppose f of x is equal to 2x plus 3 upon x minus 1. F of x is equal to 2x plus 3 upon x minus 1. If you take x is equal to 1, so f of 1 is equal to 2 into 1 plus 3 upon 1 minus 1. This is equal to 5 upon 0. Division by 0 is not permissible. It is undefined. We can say that function is undefined at x is equal to 1 because value of the function doesn't exist at x is equal to 1. So the largest set over which a function is defined, that means the set at I hope it is clear to you. So another definition of domain is the set of acceptable values of x. If y is a function of x, the set of acceptable values of x is known as domain of the function. You see, in this function f of x is equal to 3x plus 1, x can accept any real value. For any real value, the function is defined or value of the function exists. For this function will not accept x is equal to 1. So x is equal to 1 is not the acceptable value. Hence, domain of the function is any real value except 1. For this function, we can write domain of the function is r minus 1. Domain of the function is r minus 1. So note it down, another definition. The set of acceptable values of a function is known as domain of the function. Ajay sir, namaskar. Sir, मत सुनी पार्चुंती? Pratisha, is it clear, beta? Pratisha, write in the chat box. Is it clear? The set of acceptable values is called domain of the function. The set of acceptable values of a function is called the domain of the function. Okay. So if the function is y is equal to f of x is equal to root over of x, what are the acceptable values, or what are the values for which this function is defined? If you take x is equal to 0, suppose if you take x is equal to 0, then the value of y will be root over of 0. Root over of 0 is 0. Function is defined at x is equal to 0. If you take x is equal to 1, y is equal to root over of 1. Root over of 1 is 1. Okay. So if you take x is equal to -1 minus 1, then the value of y is equal to root over of -1. Root over of -1 is your iota. It is an imaginary quantity. Now we can say that the function is undefined at x is equal to 1. Since square root is there, you know, square root or even root of a negative number is an imaginary number. Imaginary numbers are not taken into consideration because you are dealing with real valued functions. Hence, here we can say that domain of the function is 0 to infinity. Domain of the function is 0 to infinity. That means at each and every point in the interval 0 to infinity, the function is defined. At each and every point in the interval 0 to infinity, value of the function exists and it is a unique value. Similarly, if a function is given as f of x is equal to log of 2x plus 1 to the base, let it be 10. F of x is equal to log of 2x plus 1 to the base 10. What are the acceptable values? You know, log function, logarithm of a negative value doesn't exist. Okay? Logarithm of a negative value doesn't exist. So this function is defined only when this is the input element, that is 2x plus 1. This is defined when 2x plus 1 is greater than 0, that is 2x greater than minus 1. This is implies x greater than minus 1 upon 2. Hence, domain of the function is minus 1 upon 2 up to infinity. I hope it is clear to you what is domain. Clear? Then come to codomain. Then come to codomain. Let f be a function from set A to set B. Let f be a function from set A to set B. Here, codomain of the function, codomain f is equal to set B. Codomain f is equal to set B. A is called domain and B is called codomain. Then come to range. The set of functional values of a function the set of functional value of a function the set of functional values of a functional value or values of a function is called range of the function. The set of functional values of a function is called range of the function, or the set of obtained values of a function the set of obtained values of a function is called a range of the function. The set of obtained values of a function is known as range of the function. Clear? Suppose come to an example. Let A be the set one, two, three, four, and B be the set 1, 2, 3 up to 20. Let A be the set 1, 2, 3, 4, and B be the set 1, 2, 3 up to 20, and F is a function, F mapping from A to B. F is a function from A to B, defined as f of x is equal to x square plus 1. Okay. A is the set 1, 2, 3, 4. B is the set 1, 2, 3 up to 20. Now calculate f of 1. F of 1 is equal to 1 square plus 1. That is equal to 2. What is f of 2? F of 2 is equal to 2 square plus 1. That is equal to 5. F of 3. F of 3 is equal to 3 square plus 1. That is 10. F of 4. F of 4 is equal to 4 square plus 1. That is equal to 17. F of 1 is equal to 2. F of 2 is equal to 5. F of 3 is equal to 10. F of 4 is equal to 17. Okay. So what are the functional values here? The functional values are, yes, good. Pratisha, you are correct. So obtained values are 2, 5, 10, and 7. So we can write range F in the short form. R stands for range. F is the function. Range of the function is 2, 5, 10, 17. So always range of a function, write down range F is a subset are equal to codomain F. Range F is a subset of codomain F. This is A is the domain, B is the codomain. So 2, 5, 10, 7 belongs to set B. So 2, 5, range F 2, 5, 10, 7 is a subset of the set 1, 2, 3 up to 20. So always range of a function is a subset of codomain of the function. Okay. Now the question is how to find the domain of a function, how to find the range of a function. So separately we will discuss different types of functions, their domain, their range, their properties, their graph, okay, and their period series, everything. So write down classification of functions, write down different types of functions. Basically, functions are algebraic functions, and second is transcendental functions. Algebraic functions under the common ASP play, constant function, second polynomial function, Third, rational polynomial function. Rational polynomial function. Fourth, irrational function. Irrational function. Then fifth, absolute value function. Sixth, signum function. Seventh, greatest integer function. Eighth, fractional part function. These functions are algebraic functions. Then what are transcendental functions? Exponential function. Second, logarithmic function. Exponential function. Logarithmic function. Third is trigonometric function. Trigonometric function. Fourth one is inverse trigonometric function. Inverse trigonometric function. Okay. So quickly note it down. So one by one, we'll analyze what is constant function, what is polynomial function, what is the domain of polynomial function, what is the range of polynomial function, what is the how to draw the graph of polynomial function. We will note it down. Okay. Come to constant function. First, we should write what is constant function. It is defined as y equals f of x. Yes, output is constant value. You are absolutely correct, Mr. Raja. Mr. Raja, very good name. Y is equal to f of x is constant. Output is fixed. Okay. That means y is equal to f of x is equal to 5. It is a constant function. Y is equal to f of x is equal to pi. It is a constant function. Y is equal to f of x is equal to e. It is a constant function. Okay. So we can write y is equal to f of x is equal to constant. Raja, you are from which higher secondary school? So it is written as y is equal to f of x is equal to constant, or we can write y is equal to f of x is equal to k. K is the constant value, right? So domain of the function, this function is defined for all real values of x. If you take any real value, the value of the function exists and it is a unique value, we can say that domain of the function is R and the range of the function is K. Clear? And what is graph? You know, since y remains constant, whatever may be the value of x, y is constant. Suppose you want to draw the graph of y is equal to f of x is equal to 5. If you take the input element as 0, the output element will be 5. If you take input element as 1, output will be 5. So output is constant. So graph of a constant function is a straight line parallel to y-axis. Right then, graph of a constant function is a straight line parallel to x-axis. Pratisha, is it clear to you? ଏବେ ପ୍ରତିଶା ଧୀରେ ଧୀରେ ବୁଝି ଆସୁଥିବ function କଣ ବୋଲି? Then come to polynomial function. An input element x should be associated with a polynomial in x. So we can write it as, it is defined as y equals f of x equals a0 plus a1x plus a2x square plus up to an x to the power n. It is defined as y is equal to f of x is equal to a0 plus a1x plus a2x square plus up to an x to the power n. Okay. where A0, A1, A2 up to An are real constants, and the power of x can't be a negative number or a fraction. And power of x can't be a negative number or a fraction. Okay. For example, y equals f of x is equal to 2x plus 3. It is a polynomial function, polynomial of degree 1. Y equals to f of x is equal to x square plus x plus 1. It is a polynomial function of degree 2. Y is equal to f of x is equal to x cube minus x. This is a polynomial function of degree 3. And y is equal to f of x. Suppose x to the power 7 plus x square plus x plus 2. This is a polynomial function of degree 2. These are the examples of polynomial functions. Now come to find the domain of a polynomial function. Raja, is it clear? Pratisha? Mr. Raja? Okay. So y is equal to f of x is equal to a0 plus a1x plus a2x square plus up to an x to the power n. Now the question is, what is the domain of a polynomial function? Domain means the set of values for which the function is defined or value of the function exists. Now you substitute any real value in place of x, you will get a unique real value after calculation, because real plus real is real, real into real is real, and real to the power real n power of real is real. So if you substitute any real value in place of x, you will get a unique real value. Now we can say that domain of a polynomial function is R. So domain f is equal to R. A polynomial function is defined for all real values of x. A polynomial function is defined for all real values of x. A polynomial function is continuous and differentiable also. I will teach you it in continuity and differentiability. So polynomial function is defined for every real value. Hence domain of the function is R. Okay. Then come to range. What is the range? The set of obtained values of a function is called range of the function. The set of obtained values of a function is called range of the function. So write down a note point. Range of an odd degree polynomial function range of an odd degree polynomial function is R. Range of an odd degree polynomial function is R, and the range of an even degree polynomial function and range of an even degree polynomial function depends upon its degree and structure. Range of an even degree polynomial function depends upon degree and structure. A range of an odd degree, very, very important point. This you have to remember. Range of an odd degree polynomial function is R. Okay. So, guys, your session is over. Rest of the thing we'll discuss in our next session. Pratisha, it is my advice to you. Join each and every class. Okay. You will get benefit out of it. This session is over now. Rest of the thing we'll discuss in our next session. Okay.